Guys, welcome in this next video of this energy and power signal. So in the DSP, so in this video we will discuss the detailed derivations of energy and power signal in digital signal processing. So basically let's start the video. Basically the energy signal and power signals that we have discussed already in the previous video. So this energy and power signal derivation we will discuss or we will derive according to the Ohm's law. So the energy signal does not indicate the actual energy of the signal, because the signal energy depends not only on the signal but also on the load resistance, that this load resistance. And here the energy is interpreted as the energy dissipated in the normalized load of the suppose R is the 1 ohm resistor. So here in this figure, here this is the V voltage, R is the resistor, that is 1 ohm, and I is the current. So here what is the value of V? That is V is equal to IR. So if we find out the I current, I is equal to V upon R, that is here the V is equal, V is the x of t, that is V here, this is the V, and R is the 1 ohm. So the I of t will be, that is the x of t upon R. So the instantaneous power in a circuit, that is the power. If we find out the power P, that will be equal to power is equal to the formula of power, that is the V into I. So V is the voltage, so that will be V is the voltage, that is the x of t, and I, what is the value of I? This value we will put here in this equation. So that is the x of t upon R from this equation. So here the node of power P will be, that is x square of t upon R. So our power will be P of t, this is the power. So further we know the total energy dissipated in the integral of the instantaneous power. So therefore the energy dissipated, how much energy dissipated here? So the total energy dissipated here, that will be the minus infinity to infinity, that is the x square of t upon R into dt. This is the equation for total energy dissipated. So we will find out this, substitute or put R equal to 1 here, then we will get the value of energy dissipated. This is the ED, means energy dissipated, that is equal to minus infinity to infinity, and the x square of t dt. So here the R will be 1, resistance load will be 1. So the energy dissipated in the resistor E, so therefore the signal energy E may be interpreted as energy dissipated in a unit resistor. So the voltage x of t is applied across the unit resistor. So there are the two types of signals are there, the real signal and complex value signal is there, and for the real signal value for real signal, that will be, let's change the color, and that will be the energy value of the energy for real signal, that will be equal to minus infinity to infinity and x square of t dt. So this we consider as this is equation 1. So the node for the complex energy signal, that is E will be, that is minus infinity to infinity, and magnitude of the energy signal, simple real energy signal. So x of t whole square dt, this considered as equation 2nd. And similarly the energy in the, if we want to find the energy in the discrete time signal, then x of t replaced by x of n. So for similarly for the discrete time energy signal, so that is the E of n, or simply E, that will be summation of n equal to minus infinity to infinity and mod of, or magnitude of x of n whole square. So this will be equation 3rd. This will be the discrete time signal, discrete time energy signal derivation. So the energy signal must be finite. So if so it will be meaningful. We only need the finite energy signal, that is the meaningful energy. So for the energy to be finite, so the signal amplitude, that x of, that is the x of t, or for the discrete time energy signal it will be x of n, that must go to 0. So then the time t, that goes to the infinity, otherwise the integral, that the back equation, that is the first or second equation, so that node will be converged. So if the signal amplitude does not become to 0, then the signal energy will be infinite. So this one thing need to remember here. So consider, we are considering the periodic signal, the cycle that cycles repeating again and again, and with the signal amplitude, so the signal not become to a 0. So these are, that are the periodic signals. So we will define the some parameters of the average that is average power parameter for periodic signal. So let's start here. This is the periodic signal, that will be infinite. So same signal repeating after some time instant, and so on. So for these type of signal, we find out the power P for periodic signals. So here the same, the 3 signals, repeat the 3 signals that we have already find out first in the 3 equations. So same signal, so that we will here find out. So for first, for same for real signal for the average power law, for average power. So in the first equation we have find out the energy for energy signal, real energy signal. Here we are finding the power signal. So here the average power. So average power. So power will be 1 upon t. So for limit t approaches to infinite, so 1 by t, total number of the t. So here the minus t by 2 to t by 2, and the same signal, the power signal, that is x square of t dt. This signal is the power signal for real signal. So we will consider it as equation 4th. So now we are finding for the complex value signal, average power signal or complex power signal. So here the power P will be equal to limit same t approaches to infinite 1 by t, and here only the difference is x square t changes to magnitude of minus t by t to t by t, that is x magnitude of x of t whole square dt. So this will be the equation 5th, and the last one is the similarly the discrete time power signal. Discrete time power signal, it changes to power p, x of t changes to x of n, same limits, so integral changes to summation, p is equal to summation of n approaches to infinity, and limit n approaches to infinity, and 1 by t changes to 1 by n, and summation of n equal to minus n by 2 to n by 2, and the magnitude of x of n whole square. So this will be the equation 6th. So there are 3 equations for the power signal and 3 equations for the energy signal. First 3 equations belongs to the power energy signal, and second 3 equations belongs to the power signal. So therefore these power signals are the mean square values of the signals, or these power signals are equal to the mean square value of the x of t signal. So these are the energy signal and power signal equations for this today lecture. So guys, let's explain one time. So here the energy and power signal derivations. So these are based on the Ohm's law. So here this is the x of t is the voltage here, or is the resistance, that is the 1 ohm, and this I of t is the current, and according to this we are finding out the power. So according to Ohm's law, voltage is equal to current into resistance. So here V is the x of t, R is the 1. So we find out I is equal to VR. So I is the V upon R, and we substitute the value of I and V here. I is the I of t, then the value of the I of t, that will be the x of t upon R. X of t is the V, and R is the resistance, x of t is the voltage. So here for finding the power, E power is equal to the formula for power, finding the power, that is the voltage into current. So substitute the value of the V here and I here. Value of V will be the x of t and I will be the x of t upon r. So substitute the value here and get the value of power, that is x square t upon r. Then the energy dissipation ED, that is the formula for that, minus infinity to infinity, that is the power of, so for limit of taking the limit from minus infinity to infinity, and then power with respect to dt, and here the substitute the value of the r equal to 1, then energy dissipation will be that is minus infinity to infinity per limit and x square of t dt. And there are the three signals for the energy signals. This is the energy signal E, and E is the minus infinity to infinity x square t dt. And for second signal, that is a complex energy signal, that has E is equal to minus infinity to infinity per limit, and it has taken the magnitude of that particular signal, that is x of t of whole square dt. This is the second equation. And similarly for discrete time signal, discrete time energy signal, that is equal to summation of n is equal to minus infinity to infinity mod of x of n whole square. So this will be the equation third. And similarly for the power signal, the power signal for the periodic signals, power signal are the periodic signals. For periodic signals, there are sine, cosine, etc. And there are also have the three equations for the real signal. First one is the real signal, the average power for real signal, that is the p is equal to limits t approaches to infinity 1 by t and for integration minus t by 2 to t by 2 x square t dt. So here t is the total number of the cycles. So minus t by 2 to t by 2 are the, this is minus t by 2 to t by 2 here. And x square is the power signal of with respect to t dt. So this is the real signal, and second one is the power signal for complex signal, complex power signal, that have the power limit t approaches to infinite 1 by total number of a t and minus t by t to t by 2 to t by 2 integration with the magnitude of the signal, that is x of t whole square dt. So this equation fifth represents the complex power signal, and last one is the discrete time power signal where t changes to n. So power p limit n approaches to infinite 1 by n. So for minus t by 2 changes to minus n by 2 to n by 2 summation, and the magnitude of the x of t changes to x of n, magnitude of x of n whole. So these are the three equations for power signal and three equations for energy signals. So that's all for this lecture, guys. So if you like this video, please subscribe my channel, and if you have any query, please write in the comment section. So thank you, guys.